Students, I hope you are all well and healthy and ready to learn the new things. So my name is Palak Patel. I am working in the Mahatma Gandhi Institute of Technical Education and Research Center, Navsari in Civil Engineering Department. I am going to teach you the subject is design of structures. Design of structure. In this subject we are learn some basic design of the structure like beam, column, slab in the RCC, and right now we will learn steel structure design. Steel structure design. So today we are starting a steel structure design. So first of all we will learn a bolted connection. Bolted connection in a steel structure design. So bolted connection, we have two types of bolted connection. First is a lap joint. In a bolted connection, first joint is a lap joint and second is a butt joint. So we have two types of design here. For the bolted connection we have two types of design. First is a lap joint and second one is butt joint. Now lap joint is subdivided between two parts. First single bolted and the second one is double bolted. We have a two type of design here. First is a single bolted and second one is double bolted. As well as butt joint is also subdivided between two parts. First is a single cover and second one is double cover. We have a two type of design here, single cover and double cover, right? So now in this lecture we will learn lap joint and single bolted lap joint. But first of all we have to understand what is lap joint and what is single bolted and what is double bolted lap joint. Okay, so now we can learn what is lap joint. We have to learn what is lap joint. Simple method is lap joint is used for the bolting connection. Okay, any type of steel structure we can connect by a lap joint. So lap joint, I can say here is a one plate. I can say steel material here one, and here is a second one, and these both are connected by one bolt. It's called lap joint. Two plates are overlap on each other. It's called lap joint. Plate number 1 and plate number 2. I cannot say is the plate, it can be any type of structure. Any type of steel structure can be connected by a lap joint if they both are overlap. Okay. Now we will understand what is single bolted and double bolted. Single bolted lap joint and double bolted lap joint. So the single bolted, I will draw a top view of this plate here, plate number 1, and here is a plate number 2, right? Plate number 1 and plate number 2, same thing here. Okay, here is a plate number 1 and here is a plate number 2, 1 and 2. Okay, we have two plates here. Now both plates are connected by a lap joint. But what about a single bolted? Single bolted means your bolting will be in a single line. Bolting in a single line, it's called a single bolted, and in the double bolted, bolting in a two line, it's called double bolted. If more than one line, it's called double bolted. Simple language, I can say is the bolt in a one line, one parallel line. Look at here, one parallel line. It's a single bolted. But we can have the more than one. It's called double bolted. We have a 3 bolted and 4 line, but we call it single bolted and double bolted. Okay, so in this lecture first we learn ટ્રેન જાય છે યાર, અવાજ કાઢવા માટે મારે કંઈ બોલવું નહીં પડશે. Okay, so in the single bolted we will design a single bolted lap joint here. Okay, so you can see the example. Okay, so here is the example. So here is the example 1. Two plate 80 mm wide, 12 mm and 20 mm thick are connected by a lap joint to resist design tensile load 70 kN. Design a lap joint using M60 bolt grade 4.6 and grade 410 for the plate. Right. So I hope you read the example. Okay, you get the example. I just write down some given data here. Some given data which is given in the example. First of all, they give the width of the plate. Width of the plate which is 80 mm. 80 mm. Here gives the order dimension for the plate and as well as bolt. I just write down first given data is for the plate. First given data is for the plate, and we have two plates here. So I call this P1 and P2. P1 and P2. Two plates are connected by a lap joint and they give the thickness 20 mm and 12 mm. They give a thickness here. Okay, these are the given data of the plate, and as well as they give the one FU, tensile strength of the plate, which is 410 megapascal, which is convert 410 Newton per mm square. Okay, we require data in Newton per mm square. That's why I converted FU for the plate in 410 megapascal. Now as well as for the plate we have the given data for the bolt also. For the bolt also. So for the bolt we have a first given data is M60. M60. So it's a 60 denote diameter. 60 denote diameter which is 60 mm. So bolt diameter is 60 mm, and as well as they write down the grade 4.6. Grade is 4.6. So we required here FU, tensile strength of the bolt. So FU is equal to 4 multiplied by 100. This 4 denote tensile strength 100 part. Is 4 denote 100 parts of tensile strength. So 4 multiplied by 100. 4 multiplied by 100, which is 400 Newton per mm square. Here we have the all given data in the example. Now we will going to design a lap joint for connecting these two plates, P1 and P2. So lap joint means overlap on each other and we have fixed by a bolt. But we have to design this by using IS 800 2007. We use this Indian standard code IS 800 2007. This is the Indian standard code we use for the design this lap joint, and for the bolted connection we use section number 10. We use section number 10. Now we will start a design here. Okay, so we are using IS 800 and 2007. If you have this, please take it with you, because we required it to design it. We required this IS code for the design. Okay, in the given data in the example given. Okay, now there is a one more thing I just tell you about the figure here. It's a two plate connected by a lap joint for resist 17 kilonewton, means 70 kilonewton tensile force will be resist by a bolt here by a bolt. Now first thing for this bolt is here to resist a 17 kilonewton tensile force. So bolt has to resist shear force which is nearer to 70 kilonewton. So in this example we require to calculate numbers of bolt to resist 17 kilonewton tensile force. So we required a shear force here. So in the same thing, section 10, open the section 10 and you can see here is a section 10, one clause here, one clause is given. The section 10 has a clause number 10.3.2. In this clause we have one equation, VSB is equal to VDB. So VSB is a shear force which resists by a bolt. So VSB is a shear force which resists by a bolt. But VDB is called bolt value. So for the find out the shear force, we required bolt value here. So what is bolt value? In the same clause, same 10.3.2, we have to given VDB can be find out by a shear and by a bending. By the shear and by the bending. And the shear force can be calculated by 10.3.3 and bending 10.3.4. And after a shear and bending, whichever is smaller, this smaller value is called a bolt value. Smaller value between the shear and bending, these two smaller value between these two shear and bending, whichever is smaller, we call this as a bolt value. And these things written in the IS code, right? So we have to find out VDSB, we required VSB. For find out to VSB, we required VDB, and then both we required VDB, we have to calculate shear and bending both. So let's start with the calculate shear force from the clause number 10.3.3. Okay, it's the shear capacity, and second one is bending capacity of the bolt, and whichever is smaller by these two value is called bolt value. By this bolt value we can find out the shear force, and by using the shear force we can calculate number of bolts. Understand? Now we will starting to calculate shear capacity of the bolt. Now here is shear capacity of bolt 10.3.3. Here is equation VDSB is equal to VNSB divided by gamma MB. And here is a VNSB equation, Fu under root 3 NN ANB NS ASB. Okay, so here is a clause number 10.3.2. So in this clause number we have a shear force, factor shear force VSB is equal to VDB. VDB is a design strength of bolt. We required VSB, factor shear force. But first of all we have to find out VDB, design strength of bolt, and this will be calculated by shear and bending. Whichever is smaller between between two shear and bending, whichever is smaller, we call it as a shear design strength of bolt. In the simple word, I can call it bolt value, right? So when we find a shear, VDSB 10.3.3 and bearing VDPB is 10.3.4, right? Now we are going to calculate shear capacity of bolt. Shear capacity of the bolt from clause number 10.3.3. Remember this number, clause number 10.3.3. In this clause we have one equation. VDSP is equal to VNSP upon gamma MB. This same equation given in the IS code, clause number 10.3.3. Now first of all we have to calculate. Here is a table number 5 from page number 30. This is used for the calculate gamma MB. Gamma MB is a partial safety factor. You can see here you have gamma F, gamma MB, gamma MR, gamma W. We have to bolt bearing type gamma MB from the shop fabrication and field fabrication. Partial safety factor from the shop and field. If from the shop we will 1.25 and on the field we 1.25, right? So here is a gamma MB value is 1.25. Gamma MB here, gamma MB. So gamma MB calculated from the table number 5, page number 30. Page number 30 from the same IS code, IS 800 2007. From this we can find out gamma MB from the table, right? So gamma MB we can find out. So from the table we have the value is 1.25. So gamma MB value is 1.25. Now we require the value of VNSB here, VNSB. So VNSB's equation is given in the same clause 3.3. VNSB is equal to FU under root 3 into NM ANM plus NS ANS. So these things is given in the IS code. Now we have to calculate VNSB from this equation. So we VNSB is equal to FU under root 3 into ANN plus NS ANS. Okay. Now we will calculate all the details here. First is FU. Now we are going to calculate shear capacity of a bolt. So FU is a tensile strength. Which given in the example, which is 400 Newton per mm square. 400 Newton per mm square. These things are given in the example. Okay, so we can find out easily. Now we have NM and NS. We have NM and NS. Both are numbers of shear plane, which generated in the bolt, Now we will calculate what is shear plane. I will explain it here. What is shear plane? So remaining you can say here is a bolt, right? You can see here is a bolt, and bolt are connected by two plates, right? Here plate 1 and as well as here is plate 2. 1 both placed have a tensile forces, opposite direction. Okay, so now what happened in the bolt? In the bolt we face this part is facing this direction shear force, and this bottom part this part is facing this direction shear force. You can see two different color here. Okay, green part facing different direction and blue part facing different direction shear force. And by this area, this minor area between these two different direction forces, we generate one shear plane here. In the lap joint, generate one shear plane where two different direction forces are interacted, and here force becomes 0. Okay, direction of forces is changing here. This in this direction and second one is this direction. So both different directions, and we generate. Okay. Now here is we have one NN and second one is NS. NN means shear plane with thread, and the NS without thread. Now what is the difference between with thread and without thread? You can see here is a bolt here. In the bolt we have some thread here. Imagine this thread is only in this direction only, and there is a shank area. Okay, so which location shear plane are generated is depend on NS and NS. Here is a shear in the lap joint, only one shear plane generated, and we assume bolt are fully threaded. That means NN is equal to 1. Because shear plane is generated into the thread area. Okay, and NS without thread means shear plane is generated in the shank area when we have no thread there. But in the lap joint we assume bolt are fully threaded. That's why NS becomes 0. So we have a two value here, NN and NS. Now we have to calculate ANN and ANS. NN, NS, NFU. Now we are going to calculate ANB and ASB. ANB and ASB. Both are cross section area. Of bolt. But A and B is called with thread, and this is ASB is without threads. Now simple logic, if we have a bolt like this, okay, it's a head and here is a bolt. Now we have some thread, right? And some portion, this portion is without thread, so it's called a shank area. Now we have to calculate ASP from here. Bolt is a circular, so pi by 4 into d square. Now we have the diameter of the bolt, which is M60 given, so 60 mm. 60 mm is the diameter of the bolt. So pi by 4 into 60 square, which is round figure 201 mm square. Now we have to calculate A and B. A and B equation is so simple, 0.75 into pi by 4 into d square. Diameter with a thread, which is 0.75 into pi by 4 into d square, which is 0.75 into 201, because diameter is 60 mm. Okay, so 201, this value is 157 mm square. 157 mm square. Now we have all the value here. First ASB, which is 201 mm square, and ANB, which is 157 mm square. Now we can calculate all the data here. We can calculate VNSP. We can calculate VNSP from this equation. Okay, so we have all the data here. Wait a second, let's check कर लो क्योंकि मैं वाला तो now we have all the data here. First is FU. FU is 400 under root 3. NN is 1. A and B is 157. NS is 0. And ASB is 201. So our value is 3625.7.59 Newton. So I converted into kilonewton. It's a 36.25 kilonewton. Now we have the value of VNSP. So we can calculate VDSB is equal to VNSP upon gamma MB. We have all the values here. So VNSB is equal to 36.25 divided by gamma MB, which is 1.25 from table number 5th. So this value is 29 kilonewton. 29 kilonewton is 29 kilonewton is the shear capacity of the bolt. 29 kilonewton is the shear capacity. Shear capacity of the bolt. So we have the shear capacity now, but we are required to calculate bearing capacity. Now bearing capacity of a bolt is 10.3.4. VDPB, VNPB and gamma MB is a VNB equation 2.5 B, KD, T and FU. What is KB? KB is the smaller of E divided by 3D0, P divided by 3D0 minus 0.25, FU B upon FU and 1. Right? We are going to calculate bearing capacity. Bearing capacity of bolt by using clause number 10.3.4. Okay. Now on this bearing capacity of bolt 10.3.4 clause number, we have one equation. V dPb is equal to V nPb divided by gamma MB. Divided by gamma MB. But gamma MB we have a equation, we have a table number 5, page number 30. Table number 5, page number 30. From this table we have a gamma MB value is 1.25. Gamma MB is a partial safety factor and we have a value is 1.25. Now we are going to calculate VNPB, which equation is given in the same as the IS code, which is VNPB is equal to 2.5 KB D, T and FU. D, T and FU. Right? Now we have all the values here. Okay, so we have a FU. FU is equal to 400 Newton per mm square. Tensile strength of bolt. T means thickness. T means thickness of plate. We have two plates here. Plate 1 has 20 mm and plate 2 has 12 mm thickness. Right? Two thickness here, 20 mm and 12 mm. So thickness we are used 12 mm. So here is a 12 mm thickness. Whichever is smaller from these two connecting plate, whichever is smaller, we take it as thickness here. So 12 mm thickness. Now here is a depend on the thickness. How we calculate this two different plate here. Okay. There is a plate. You can say here is a bolt. and we can say two different direction forces. Here is a 12 and 20 mm difference for the thickness. So different direction of forces, whichever thickness is smaller, we take it as a 12 mm here. Okay. Now we have a diameter of the bolt. Diameter of the bolt is 60 mm. D means diameter of the bolt 60 mm, which given in the example. Now one more thing is missing. KB is missing. So KB can be calculated by E3D0 P3D0 minus 0.25 FUB and FU and 1. These are the four equations. First is ED30, second one is PD30 minus 0.25 FUB upon FU and 1. By these four, whichever is smaller, we call this as a KB. Now we have to calculate all the three data one by one here. Okay. The KB, we have the four equation. First E divided by 3D0, second one P divided by 3D0 minus 0.25 FUB and FU, and last one is 1. Okay. Now we have the so many data here. We have to calculate so many data. First, for the E. E means end distance. I can call this end distance. And P means pitch distance. End distance and pitch distance. So let's explain it here. What is end distance and what is P distance? Pitch. And the last one is okay, D0. Okay. We will discuss about both the equation. D0 means diameter of hole. Hole means for the bolting we drill some. Okay, we drill a hole in the plate. So this is a diameter. Pitch distance P and end distance E. Pitch distance is a minimum spacing between two bolts, and this is a less than 2.5 times the nominal diameter of the fastener, means 2.5 multiplied by diameter of the bolt. Here is called a fastener. Fastener means a bolt. Okay. Then the end distance. End distance, the minimum edge and end distance from the center of any hole. Shall not be less than 1.7 times the whole diameter. 1.7 times the whole diameter. 1.7 times the whole diameter, so 1.7 into D0, right? Of bolt, which is D0. Okay. First of all, we will calculate end distance and pitch distance. So here you can see the plate here. Okay, and I just bolted diameter hole here, and here. Is the diameter hole, okay, for the bolting, and here is the plate. So end distance means distance between bolt hole to the nearer edge. Distance between bolt hole to the nearer edge is called end distance. Okay, it's called end distance, and end distance we can find out from the clause 10.2.4. From 10.2.4. In this clause we have equation E is equal to 1.7 D0. 1.7 D0. Okay. Now we are missing the D0. We will calculate later, but let's stop it. Now we are going to calculate pitch distance. Pitch distance between the distance, it's the distance between two bolt hole. Distance between two bolt hole is called pitch distance, and we can find out pitch distance from the 10.2.2. 10.2.2. So its equation is P is equal to 2.5 into D0. Now D0 is almost missing. D0 is almost missing. So we can calculate D0 from the table number. Wait a minute here. We can calculate D0 from the table number 90. In the table number 90, we have some bolt diameter as well as we write down the spacing between them. That means table number 90 gives some bolt diameter. So we have the bolt diameter, which is 60 mm bolt diameter. Okay, we have a 16 mm bolt diameter, and they gave us the spacing 2 mm. So 60 plus 2 is 80 mm. 60 plus 2 is 80 mm bolt diameter. So we have a D0 is 60 mm. We have a D0 is 80 mm. D0 is 80 mm. Now E is equal to, we can calculate here, E is equal to 1.7 into 80. 1.7 into 80. So which is nearer to 30 mm. Always remember, end distance and pitch distance will be in the round figure. Will be converted into the round figure value. So its value is 30.6 mm. So I converted into 30 mm. Right? And pitch distance, okay, let's change pen color. Pitch distance is 2.5 into 80. So its value is a 40 mm. So we have end distance, pitch distance, and D0, all the three values. But FUB and FU are missing. FUB and FU are missing. So let's calculate FUB and FU. Okay. So FUB, here FUB is a tensile strength of the bolt. FUB is the tensile strength of the bolt, which is 400 Newton per mm square. Which is 400 Newton per mm square. Is the tensile strength of the bolt, which is given in the example. But here is FU. FU means tensile strength of plate. Here FUB and FU both dimensions are changing, both value are changing. Here FUB is a tensile strength of bolt and FU means tensile strength of plate. And in the equation V and PB equation, we have there one more FU, but is FU is tensile strength of bolt, and here FU is tensile strength of plate. So FU tensile strength of plate is 410 Newton per mm square. We have all the values here. Now we just put all the value in this equation and calculate it. We have the E, D0, P, D0, FUB and FU. Now we can put all the value in the equation and complete a calculation here. I hope you understand end distance and pitch distance. Okay, this value will be required in the previous previous examples. Now just divide this board into 4 parts for the calculation. Now first of all, E divided by D30. So we have the value of E, which is 30 divided by 3 into D0, diameter of bolt hole is 80. So here is a value is 0.55. We have the one value is 0.55. Now P divided by 3. P divided by 3D0. So P is equal to 40 mm divided by 3 into 80 minus 0.25. So this value is 0.49. This value is 0.49. Okay. So next one is FU divided by FUB. So FUB is a 400. FUB is 410. So value is become 0.98. Right. And the last one, we have the value is 1. We have the value is 1. So here is a 4 value, 0.55, 0.49, 0.98 and 1. Whichever is smaller, we call this as KB. So here is a KB is equal to 0.49. KB is equal to 0.49. We have all the values here. So we can calculate V and PB. Okay. So service starting. Now we can calculate V and PB. His equation is 2.5 KB, D, T and FU. We have all the values. 2.5, KB is 0.49, D means 60, T means thickness of plate 12 and FU is 400. So our V and PB value is 94.05 kilonewton. 94.05 kilonewton. These are the value of V and PB. Now we can calculate bearing capacity VDPB is equal to VNPB divided by gamma MB, and we have the gamma MB value. So VNPB is 94.05, gamma MB is 1.25, and this value is 75.26 kilonewton. These are the bearing capacity. Now we can calculate one more thing. Here we have the shear capacity. Okay, first shear capacity, which is 24, I think so. Sorry, 29, not 24. So shear force capacity is 29 kilonewton, and bearing capacity is 75.26 kilonewton, and we required bolt value, so which is VB is smaller between these two, which is 29 kilonewton. So here is a bolt value, and bolt value VB can be calculated shear force resist by the, so we have the 29 kilonewton. So we have the shear force capacity of the bolt is 29 kilonewton. Now we can calculate number of bolt. We are going to calculate number of bolts for required connect two plates for resist 70 kilonewton of force. So number of bolt we can calculate by the simple equation: total load divided by bolt value. Total load divided by bolt value. So I say writing here. So total load we have the 70 kilonewton, and bolt value is 29. So we got number is 2.41. So round figure we provide 3 numbers of bolt. So when design is completed, we can connect the bolt by using 3 numbers. But how we arrange them? Okay, we just got the number here. Okay, here is a plate 1 and here is a plate 2. Okay, second one I draw it here, plate 1 and plate 2. We have 2 plates here. Okay, now we can arrange 3 numbers of bolt in a 2 direction. We are going single bolted lap joint. Okay, single bolted lap joint. So we can connect this bolt like this, 1, 2 and 3, as well as this 1, 2 and 3. These 3 different directions. These 2 different directions we have for the arrange single bolted lap joint. But I told you, remember one thing, we have E and P, and distance we assume 30 mm and pitch distance we assume 40 mm. And one more thing, we have the width of plate which given in the example, which is 80 mm, Now assume this direction of plate. What is end distance? End distance means the distance between the bolt hole to the plate. We assume this is the end distance is 30 and here is the end distance is 30. By this arrangement 30 means 60. So how can we arrange these 2 distance by 40 mm? So this will be not possible. So this design, this type of arrangement is not possible because we have the width is only 80 mm. We have the width of plate only 80 mm and 30 plus 30 is 60. So only 20 mm we have for the arrangement. So this type of arrangement is not possible. We can arrange a double bolted lap joint, but we will discuss it later. Okay, in this lecture we will learn single bolted lap joint. So here is a complete, but this type of arrangement is not possible. But this type of arrangement can be possible. 30 and here is a 40 and here is again a 40. So this type of arrangement can be possible, right? So this is called a single bolted lap joint, and we can arrange this type, right? So our design is completed here. Lap joint design is completed. In the next lecture we will learn butt bolting, butt joint design, okay, with single cover, and I will explain as a double cover here, okay. Then after we'll learn some arrangement, okay, bolting arrangement, and we check it, okay, how we arrange this, because these are the important for the butt joint as well as lap joint. We can arrange this data. Remember one thing, these 3 number we can arrange like this, 3 numbers of bolt we can arrange like this, but we have to follow some check, and this check I will explain in the next lecture, okay. Now our design is completed. Okay students, I hope you like my video and want to share with your friends and family. And if you want to connect with me, subscribe my channel and press a bell icon for get updated about my new lecture video. Thank you and take care till the new video uploaded.